Welcome to Homework Lib.
Hi, so in this case what we want is to rearrange the reactions that we are provided in order to generate the actual reaction that we want to get. So in order to do that, the first step is always to identify what are the components that we need to start with. So in this case, we want to get XCl4 solid as a reactant. And in this reaction, we have a XCl4 as a product, right? So we can take the inverse of that first reaction. So minus delta H2 corresponds to the reaction that tells us that XCl4 as a solid is going to produce X as a solid plus 2 of Cl2 as a gas. Okay, so what other things do we want in our case? So the other thing that I want in the reactants is 2 of H2O liquid, right? So I can take minus 2 times reaction 5 in order to get that as a reactant. So minus 2 delta H5, and this corresponds to the reaction 2H2O as a liquid producing 2H2O as a gas. Perfect. So now the next step is identify what we want as products. So in this case, we want as a product XO2S that appears in reaction 4, and it appears directly, so I can just simply add delta H4. This corresponds to X as a solid plus oxygen as a gas, producing XO2 as a solid, correct? Perfect. The next step is the final one that I want to get is 4 equivalents of HCl. So we can see that that corresponds to 4 times the reaction 3. So 4 times, let me switch back to red, 4 times delta H3. This corresponds to the reaction, that is, I'm going to multiply by 4 the whole reaction. So 4 times 1/2 is equal to 2. 2 of H2 gas plus 2 of Cl2 gas produces 4 of HCl as a gas. Okay, so with this we have all of the components that we require from our reaction, but as you can see, there are some of them that we need to get rid of. How do we do that? Well, first of all, let's identify what we have, what we can cancel and what we cannot. So for example, in this case, X solid is going to cancel with X solid over here. What else can we get rid of? Chlorine is going to stay. We don't have, no, actually chlorine we can cancel already, right? We have 2 of chlorine in this reaction and 2 of chlorine here in this reaction. So what we have left is we need to get rid of water as a gas. I'm going to put this in purple again. Sorry, in purple. So we want to get rid of this water, we want to get rid of this oxygen, and we want to get rid of this hydrogen over here. So how can we do it? Well, if we look back into our equations, well, in equation 1, we have actually what we need. In order to cancel the 2 waters that we have on this step, these 2, we need to reverse reaction 1 and multiply by 2. So minus 2 times reaction 1 minus 2 times delta H1 corresponds to the following reaction. Reaction 1 multiplied by 2 is 2 of water as a gas, and this is going to produce 2 equivalents of hydrogen gas plus 1 of oxygen gas. And as you can see, now everything cancels out properly, and we're going to get only the reactants and products that we require. Over here we have water as a gas, cancels with 2 of water as a gas here. Oxygen as a gas cancels with 1 oxygen as a gas here. And 2 hydrogens as a gas cancels with 2 hydrogens as a gas here. So the overall reaction, and actually this is the way that I recommend to writing down this type of equations just to keep track of everything that you did. The overall reaction is XlCl4 as a solid plus 2 of water as a liquid. It's going to produce XO2 as a solid plus 4 of HCl, hydrochloric acid, as a gas, which is the reaction that we actually wanted. And in terms of enthalpy, we need to only sum all of these results, which is going to give us, let me rewrite them over here just for making it as clear as possible. This is minus delta H2 minus 2 times delta H5 plus delta H4 plus 4 times delta H3 minus 2 times delta H1. Replacing the values, we get, on the first one, this is minus 300.7. All of this is going to be in kilojoules. Minus 2 times delta H5, that is negative, so this becomes plus 2 times 44 kilojoules. Delta H4, it's negative, so minus 583.1. Delta H3, it's also negative, so minus 4 times 92.3. And finally, delta H1 is negative, so negative and negative becomes positive, plus 2 times 241.8. And the result is minus, this is the delta H for the reaction, minus 681.4 kilojoules. And that will be all. Thank you very much.